All right, so now that you've done a little exploring with parent functions and transformations, we're going to continue on with this video to talk about parent functions and transformations to make sure you really understand what we're trying to get out of today. So we're going to focus on linear functions and some varieties of linear functions, but some other parent functions you've seen as well, and practicing our transformations, specifically the translations, which are what we might call our slides when it moves up, down, left, or right, and our reflections, which sometimes we might refer to as our flips, where it will flip over the x-axis or the y-axis. So I want you to look at the parent function sheet that you were working on earlier today and look at the constant function, the linear function, the absolute value function, and the quadratic function. Hopefully these are the equations that you came up with for those. And I want you to take a minute and I want you to draw a graph of what each of these looks like. So go ahead and take a minute in your notebook and draw a graph of each of them, labeling what they are, both the equation as well as verbally what we call them. And then if you remember what domain and range are from a previous class, I want you to write down what you think the domain and the range of each of them are. So go ahead, pause the video, do that on your own, and then unpause when you're ready to discuss. All right, so hopefully you've had a chance to draw those graphs and maybe even think about domain and range if you remember that. Hopefully this is what your graphs look like. So this is our constant function at f of x equals 1. It's just a horizontal line where every y coordinate has a value of 1 at every x coordinate. Our linear function f of x equals x, so this has a slope of 1, y-intercept of 0. If we think about, and I know we're not doing this yet, but you know, our generic form of y equals mx plus b, that's what this equation is, where m is 1 and b is 0. Our absolute value function, so our absolute value function is actually taking the linear function and this part right here that's negative, and because absolute value is always the distance from 0, so it's never negative, we're taking that and we're flipping it up and we're making it positive, so the output is positive. The x coordinates can be negative, that's okay. And we get this V sort of shape, and then the quadratic function, which we also call a parabola, is f of x equals x squared, and this is our parent function for that. Now, domain and range. Again, you may or may not remember, it depends on how much work you were doing this summer and how much you remember from your previous classes, but domain is your x values. So when we say that, domain is the possible input, which is the x, values to any given function. All of these functions, we can put any x value we want into the function. So all of them have a domain of all real numbers. Now, again, depending on what you may or may not remember, we also have what we call interval notation. And so a different way in which we can represent all real numbers is with interval notation. And in this case, it would be -infinity to infinity. Now remember, with interval notation, the parenthesis is telling me that I am not including the number. The number on the left should always be lower than or equal to the number on the right, because we're reading this from left to right, and the comma is implying that we are including everything between these two values. Range then, range is the y values. And again, when we say the y values, a better way to phrase that would be the possible outputs of the function. So this function right here, the only output is 1, so the range is y equals 1. This function right here, it's going to go down forever and it's going to go up forever, so the range is all real numbers. Here, the lowest the y value is 0, but it does get to 0, and then it goes up forever, so its y is greater than or equal to 0, and the same thing is true with this one. Just to continue on with the interval notation, so we already know that all real numbers is -infinity to infinity, but if we have something like this, y is greater than or equal to 0, this one, we're going to start with a bracket, 0, infinity. So the bracket means that we include the number. The bracket is there because of the equal to sign in our greater than or equal to, so that's why this is a bracket. 0 is the lowest value, so that is the one on the left, comma infinity, because this is going to go up forever, and then a parenthesis. You may be asking yourself, and this is a very good question, why do I have parentheses around the infinity and the negative infinity? Aren't those included? Well, infinity and negative infinity are not actually values that we can ever get to. Well, they're not actually values. They're just ideas of continuing to go on forever in a certain direction, so we don't ever actually get there. They are not a specific location such as, or similar to, like 0 is a value that we can get to. So these are the domain and ranges, and these are our parent functions that we are mainly going to focus on in this unit. However, since you did this for part of your work already today, I want you to also go ahead and draw a picture of the radical, the cubic, the reciprocal, and the exponential function, as well as writing the rule, by rule we mean the equation, of each of them. Similar to the last slide, if you can identify the domain and range, great. If not, we'll talk about it. So go ahead and pause the video, try this, unpause when you're ready to check. All right, so hopefully your graphs look something like mine. Again, these are just sketches. We aren't actually plotting points yet. So the idea behind this is just to get a rough idea of when I hear radical or cubic or reciprocal or exponential, or when I see this type of equation or rule, I have a general idea of what that's going to look like. And vice versa. If I see this graph, I know that that's a radical or that it's going to be this type of equation. And if I see something like this, I know that's going to be reciprocal or this is exponential. Because we're going to learn more about most of these later on, but we want to have a general idea for what they are. So with that, let's also quickly talk about the domain and range. For this function, remember domain is x values and range is y values, or we can think of this as inputs and this is outputs. And so here, we know that we don't like to take the square root of a negative. So therefore, the lowest value that we're going to input here is going to be 0, but we can include the 0 because we can take the square root of 0. And the lowest output then is also 0. And then we can continue to put in positive x values, and we will continue to get positive y values, so that it's 0 to infinity with a bracket on the 0, parenthesis on the infinity. Cubic looks kind of like this. So we can put in any x value or any input, and we can possibly get any output as well. So both the domain and range are negative infinity to infinity. The reciprocal function, this one's a little bit different. So this function has what we call asymptotes. If you don't know what an asymptote is right now, that's okay. You don't need to right now. But just understand that it's basically something where the graph is going to get infinitely close to but never actually get there. So that's why we have kind of this shape, and the asymptotes are actually the axes in this case. So the y-axis and the x-axis. So we don't ever touch them. So the domain is negative infinity to 0, not including the 0. And it's 0 to infinity. So this little u here, it's kind of like a u, it stands for union. The range is the same thing as well. So negative infinity to 0, union, 0 to infinity. Notice that I have parentheses on the zeros and the infinities because I'm never actually getting to the zeros or the infinities. Last one, exponential function, fx equals 2 to the x. So here, any input is possible. So our domain is negative infinity to infinity, but the range here, if you imagine, if you plug in any value for x here, the outcome will always be positive. If you plug in negative values here, even if you plug in 0, you're always going to get a positive value in return. So the range is actually 0, not including the 0. That's why it's a parenthesis to infinity, because we can never, this function will never equal 0 as it is. Again, we'll learn more about, especially these two, actually all 4 of these really, in later units. So if that's a little bit confusing to you now, that's okay. It's more just to kind of get a general idea and a little bit of teaser and foreshadowing for what's to come. Something exciting, something to look forward to. All right, for the next 2 examples here, I want you to go ahead and describe the transformation from the parent function for each. So given g of x is x minus 4 and given p of x is negative x squared, just describe what is the change from the parent function to this function, and what is the change from the parent function. Pause the video, do that. Unpause. All right, so can someone tell me what they got for g of x? Yeah. Okay, A little quiet today. That's right. So this one I would say is going to be down 4, or we could say it's going to slide 4 down, something along those lines. It's going to shift down 4. Another way we can think about that is it's going to subtract 4 from all of the y coordinates. Okay, excellent work. How about p of x? What is the change from here to the, from the parent function to here, sorry. So if that negative is outside of the function, very good. We are going to reflect over x axis. Another way to think about that is we are going to multiply all of the y values by a -1. Any questions? Great. All right, almost there. Just a couple more examples. So here, again, I want you to try this on your own. We have 3 different problems. I want you to try all 3, so take a couple minutes, that's all right. I want you to graph the parent function and this function and then describe the transformation. So pause the video, do all 3 of those, unpause when you are ready to check. All right, so hopefully you have something that looks like what I have here. Actually, yours might look even nicer because it looks like a 4-year-old drew some of my graphs. Anyway, no offense to 4-year-olds. That is not offend anyone. So on all 3 of these, the red graph would be the parent function and the green graph is the transformation or the transformed function. So here the graph went up 3, but it's a line. Here we have a parabola and this went to the right 2. So the -2 in the parentheses is shifting it right 2. Huh, that's interesting. And here the negative outside of the absolute value reflected over the x-axis. Again, I do apologize. It's pretty sloppy, but hopefully that makes sense. All right, last example. Use your graphing calculator to graph this function and its parent function, then describe the transformation. So I want you to go ahead and do that. Pause the video, unpause when you're ready to discuss. All right, so I use this fun graphing program that I have on my computer. And this here in the red, that is the parent function, absolute value of x. And this here in the green, this is my transformed parent function or transformed function. Negative or opposite absolute value of the quantity x plus 5 minus 3. So what were the actual transformations though? Well, the plus 5 in the absolute value is going to make it go left 5. The negative outside of the absolute value is going to reflect over the x-axis, and so that's why it's this upside down V or the mountain shape, I guess, depending on whatever, use your imagination. And then the -3 is going to go down 3. Now, I will point out that the order in which we did these transformations was very important. It is the order that, based on how we're given the function, but if we switch the order of these last 2 especially, it will change the outcome of the graph. So keep that in mind. All right. Good talk.